Good morning, everybody, to another week in this lovely Monday, where we are continuing our discussion on different number systems. And the further we go, the less different they become. Now, hopefully, you watched the video on base 5 numbers. And correct me if I'm wrong, but I'm pretty sure that went as far as converting between the base 5 and the decimal numbers. So base 5 number system. Now, really, all we're doing here, we're not actually reinventing the with what we did on Thursday. It's still exactly the same as the one-hand system. One-hand system. Go forward in time to the Devanagari system or symbols. I don't know if I spelled that right. I probably didn't. Go forward in time a little bit and use the 16th century. I don't think they have a name. Symbols. No difference between these at all, other than appearance, really. So if I have, for example, um, what shall we say here? Maybe a hand, two fingers, and maybe three rocks. Then that's a three-place number when I see it in its modern, updated place value version. So I have one hand, two fingers, and three rocks. You could take any symbols you want. We can go and update it to the most modern symbols as they evolved. And I just write it the way my handwriting is. 1, 2, 3. But it's good here to emphasize that this is counting groups of 5. Actually, it's good to do it here as well. Otherwise, just by looking at the 1, 2, 3, I'm not sure. Is this 123? No, it's not. It is one group of 25 plus two groups of 5 plus three ones, which is then, of course, 25, 35, 38 in decimal. So in order to be able to read these numbers correctly and identify what number system I'm in, I'm going to have to use a little subscript to indicate, am I counting in fives or am I counting in tens like the decimal numbers do? But it's important to realize that we're not doing anything strange, really. It's still the same one-hand system, counting in fives underneath. All right. So you've done the converting between decimal and base 5. That was done on Friday. Our task then is really with any of these, we should be able to flip back and forth between any of these versions in history and do arithmetic within this number system. So I'll leave this up and make a new page. And of course, feel free to interrupt if you have any questions. I looked at our schedule again and we actually have a lot of time. This whole week is devoted to finishing up this last part, and then we have a little test next week. So we are doing our first kind of arithmetic. Now our goal is the same as before. Our goal is to stay within the number system. Regardless of the version, it is essentially the same number system. But I want to stay within, yeah, I just want to stay within the same number system. Well, I'll show you what I mean by that. If you want to do it with the one-hand system or the one-hand version, the original, if you want to use the Devanagari symbols, if you want to use the modern symbols with the subscript, it's all good because it's all the same. So instead of exercise, well, I'll do exercise 7.4, but I won't do it exactly like this. Let's go with an A0. What comes before A? I don't know. Before I do the A, B, and C in the book, let's do one with the original one-hand system, then slowly update it because I have to be able to do addition in all of these and see the differences and see the similarities. Okay, so I'm adding a couple of questions at the start of exercise 7.4, which is our addition one. So let's say, for example, we have a hand. Actually, I'm going to write it all in one line like this. Say we have a hand, we have two fingers and three rocks, let's say, and we're adding to that maybe another hand, maybe four fingers, and maybe another three rocks. What is our first goal? Well, regardless of how this looks, the method for written arithmetic doesn't change. And the first thing that method says is line things up so you can keep track of similar things and groupings and all kinds of stuff. So I give myself some space. So it's kind of similar to Roman, I guess, if I have to think about what is the closest. In terms of spacing, lining things up, and so on. But of course, it's not the Roman system. I'm counting in groups of 5 here. So let's see how this feels. So I'm going to my first column, which is the ones column. I have 3 plus 3, that's 6. However, I am not allowed to draw 6 rocks. I group up 5 of them, and that becomes a finger. And I have 1 left. Now I move on to my finger column. I have 1, I have 3, I have 7 fingers in total here. Group up 5 of them, that becomes a hand. I have 2 fingers left, and 3 hands are allowed. And there we go. So I can do the arithmetic in the original one-hand system. Of course, I should be able to. So that's our first uh, addition. So here we want to be able to do the addition for all 3 different faces of the base 5 number system, which this is. The original face, an in-between face, and then the most modern symbols. Okay, so that's 1 that I want to add at the beginning of 7.4. Then I guess I'll call this A1, the next one, before I get to the book 7.4, where I want to use the Devanagari symbols. I'm just making these up. I don't want to make the same question, right? Let's say maybe a number. Well, let's go. No, yeah, let's go with the 0. It's fine. Maybe something like that. Maybe let's go. My threes never look that good. let's go for there and maybe like that. Yeah, there we go. Now, technically, we are not going to use this for anything other than base 5, but technically, these symbols were originally in the history of the decimal system. So to not confuse it uh, with that, we should write a little subscript, I guess, technically. But we can come to the agreement that we're not going to use these symbols for anything other than base 5. So between us, we don't have to write the subscript. But I suppose technically you kind of should. So our method doesn't change. Line things up. Give myself some space. I want to give myself some space here. So I'm not going to write the subscript every time here. Line. Oh, I need to practice my threes. They don't look very good. Something like that. Those twos don't look the same, do they? Make it a little fatter. Now it looks like a decimal two. Anyway, I'm going to go to my ones column. Now I'm still going to keep my language when I say these things in words. Otherwise, it would be too foreign for me. 4 plus 2 is 6. I don't have a 6 symbol. I am going to carry over one group of 5 and have one left over. Then I move on to the next column, which is the 5s column, groups of 5. And I say 1 plus 0 plus 4. It's not really what's happening, right? It's one group of 5 plus 0 groups of 5 plus 4 groups of 5 is a certain number of groups of 5. But because that is attached to every single thing I say in this column, I'm going to stop saying it and understand where I'm at. It's all relative to this column. So 1 plus 4 is 5. I don't have a 5 symbol. Doesn't exist in this number system. I can make one group of 5. Oof, that's too curly. My ones need work too. Oh, everything needs work. One group of 5 and nothing left over because it was just 5 perfectly. And then I go on to the next column. I know this one symbol is horrible. 1 plus 2 plus 3, that is 6. 6 doesn't have a symbol. 6 is one group of 5 plus another 1. I'm writing so many ones, I need to practice. And then in the next column, as long as they're consistent, they all look the same, so it's good. I just bring down the 1 in the last column. There's nothing else to add to it, and I have my answer. It's still the same, still counting in 5s. Nothing has changed. All right. Now, do I have space? Sure I do. I will get to part A. Now all we're doing is updating the symbols to their modern versions. And now I have to give a subscript because they are the same symbols I use for my decimal system. So pros and cons. Pro is at least they're more familiar and I know how to write them, the symbols. Con, I don't have, I should be careful to not read this as a decimal number. I will never ever say, except for now, 2,410. That is just not this number. It is not the same number system at all. And that's a decimal way of saying this is counting in 5s. But my method doesn't change. Line it up, give myself some space. Whoopsie, that was supposed to be a 0. Always write the subscript, or it's not the same number. And I have to subtract some marks. It's just not the same. There has to be a subscript everywhere now because my symbols are now the same symbols as I use for the decimal system. So I have to distinguish between the two number systems. 0 plus 0, 0. Write my subscript now before I forget to write it. Next column is the fives column. One group of five plus three groups of five is four groups of five, or relative to this column, 1 plus 3 is 4. Next column, 4 plus 4 is 8. I don't have an 8. That doesn't actually exist in this language. But I have a word for it temporarily to help myself, so it's not too foreign. 8 is one group of 5 and 3 left over. Next column, 1 plus 2 plus 2. That's 5. I don't have a 5 symbol. Doesn't exist. It's one group. Oops, sorry, I should do it this way. It's one group of 5 carried over and 0 left behind. Next column only has the 1, and I'm done. Give yourself a slap on the wrist if you read this as 10,340. It is not. It's 10340 base 5. I don't know what it is in decimal. That is not what I'm supposed to be doing. I am supposed to add the numbers, not convert them. That is a different question. All right. Let's make a new page. Now we can totally come back to these. I just want to make sure I cover subtraction and multiplication as well. I think we can squeeze in one more. Because I've added two questions and I'm going to do the same for the others. I want to make sure our time is good. So we have here 110 base 5 plus 4234 base 5. I'm not showing the book. You can verify that these are the exercise questions. So I line it up. 1, 1, 0 plus 4, 2, 3, 4. My 5-word becomes a little scribble, but the idea is there. Now I'm adding. 1's column, 0 plus 4 is 4. Next column, 1 plus 3 is 4. Oh, this is too easy. Oh, wow, this is way too easy. I should not even have done this. Next column, 1 plus 2 is 3. Next column, 4. Wow. So best case, there's nothing to carry over, and it's very, very straightforward. It can sometimes happen. Don't always expect the worst. This could happen. And if it does, great. But there could be some carryover as well. I'm just counting in fives. Whatever the number is what it is. So I'm going to skip the last one. Feel free to use it as another problem. I just want to make sure I can get through subtraction and multiplication. That said, please check the schedule. Tomorrow is just a Q&A session, catch up if you need it. Bring your questions, do whatever you need to do. Oh, that is the bad looking S. So we are taking our time this week because it is the last thing to do before or to finish part 3. No, not part 3, part 2. For part 3, we're not going to start that until after our quiz, so we can focus just on this. There's no overlap like there was last time. So that is nice. So exercise 7.5, A0. I'm going to add some questions before the actual exercise questions. We're doing subtraction, so let's give ourselves a hand. Get it? No? Okay. Let's maybe take a finger, maybe 2 rocks. And we're taking away, let's take away a hand. I'm not going to take away any fingers, but let's take away 3 rocks. Actually, no, I'm going to take away a couple of fingers too. Why not? Why not? Make it interesting. And let's take away 3 rocks. There we go. I'm not going to make this easy. So my method says line it up. I'm going to give myself enough space here. There's the finger column, there the rock column. I'm taking away a hand. a couple of fingers, and 3 rocks. All right. Now in the rock column, I have 2 take away 3. Can't be done. I need to go borrow a finger. I'll borrow this finger. As soon as I bring it over, it splits into 5 rocks. Now, this is a temporary thing that I like to look at. So that is the one exception where I can list a whole bunch of symbols. It's not a number representation for me at this stage. It's just helping me to see how much I have. So the rule of listing 5 things, I let go for a second. So I have now this 5 that was brought over plus the 2 gives me 7 in the pink square. Take away 3 and I have 4 left. For my final answer, I can't have 5 in a row. But the pink was temporary, which is why it's pink. So then, of course, this finger is not there anymore. Then
I
I'm
just
moving
have a
on. Yes,
question, if
yes,
that's okay.
yes.
I'm just wondering, so on the test, is it okay, like if we need to see that, can we draw those 5 circles, or should we do that on a separate paper? Like,
No,
is that
anything the way I do it here, it's is the way you can do it.
okay? Okay,
Because I want to
sounds
see, I just want to help myself remember what I've brought over. It's not it's not in the same way a finished representation of a number. It's just a helper for me. So it's okay to just draw a bunch of rocks. I think
okay.
that's the easiest way to do it. But no, if I do it like this, I have to lead by example. If I'm doing it like this, then this is how you can do it as well. And I want to see the borrowing happening. But that's the only way I can verify that you're doing it right. Right? It's not just about the answer. You have to show that the method was followed, and borrowing is really the only thing I can show. So I definitely
Right.
want to see stuff like this. Yes.
Thank you.
So then moving on to the finger column, I now have no fingers and I need to take away 2 fingers. So I'm going to have to go borrow. I'm going to borrow this hand. When I move it over, it splits into 5 fingers. Right? Come on, show the 5 fingers. There we go. And that hand's not there anymore. So in my finger top position, I have 5 fingers. I need to take away 2. That is easy enough to do and have 3 left. Then in the hand column, I clearly have 1 hand left and I'm done. So again, just like before, we're not reinventing the method. We're not reinventing any steps. Nothing changes. It's really just the appearance and the group size, counting in fives. So that's one version, sort of the original version. Not that they did arithmetic really at that stage in time, but still, it helps us to mix up the appearance. Then I know I really understand what is happening. The next one we'll insert at the start of 7.5 is our in-between step in the symbol progression of this base 5 number. Let's say we have, let's give ourselves enough, make sure we can do the subtraction. Um, hmm, I need to practice my ones. Let's do that. Take away. What should we take away? Maybe, yeah, maybe that. Now, just to emphasize here, we are using this only for base 5 purposes, just in case some other random person watches this video. Okay, I line it up, nothing changes. In my method, I'm just giving myself some space. Take away. I can't really make this look very different from the way I write the 2 in decimal. Okay, so the ones column. 1, take away 2. It's not going to happen. Let me get my pink out. Now, this is my version to help myself, and over time I felt that this was maybe the least confusing. I need to go borrow here, right? And I have nothing to borrow. Oh, I have nothing to borrow. So I need to go borrow for the middle column first. Oh, that was blue. So let's go blue. So now I'm going to borrow. I'm just going to borrow one of these, 4. So they're going to update to 3. I'm going to borrow 1. That 1 was technically in the hands column. So what I could do to help myself is maybe see the 5 fingers. That could help some people. See the 5 fingers. Because the system doesn't change. It is still the same thing. That's still the finger column. But technically, how you represent these 5 things is up to you. I'll be sort of authentic and use the fingers to match the column and make it look a little bit more familiar, and you can match it then to the previous example we did. However, this isn't the column we're in yet. We are aiming for the ones column. So now at least I have something to borrow. I have something to borrow here. Now I can't write 5, right? I have 5 fingers. I can't write 5. There is no symbol for 5. If you write a 5 here, that's immediately minus 1 mark because that's not an allowed symbol in this number system, which is why I rather draw some pictures of 5 things and I just use fingers. Regardless, I have to take one of them over to my ones column, and then for my convenience and understanding, I'll just draw the 5 rocks, which they technically are. That guy's gone now. He's not there anymore. So it's the same system, right? It's just the face of that system is changing. So I can mix and match to help myself. And with the borrowing, uh, I find the simplest is to draw some pictures of stuff, just like we did for Babylonian. We just drew 6, 10 symbols. It's not a complete number representation on its own. I think that's okay. So now I have the 5 that I borrowed plus another 1, so I have 6 here. I can only list them. I don't have a one place representation for 6. So I kind of am stuck. 6 take away 2 is 4. I have a symbol for that. Now to the middle column, I have 4 left, and I take away 2, that's 2 again. Next column, 3 take away 2, 1, and I'm done. So this is my suggestion for the borrowing, to draw some pictures. Uh, because once I borrow one of that column, which splits into 5, but technically in this language, in this system, there is no 5. 5 is a two-place representation, and I find that more confusing if I do that rather than drawing some symbols and just making 5 marks, however you want to make them. I feel that's a little bit easier. But ultimately, it is up to you. If you want to borrow from the blue and write 5 as 1, 0, that's totally up to you because that is what it is. And then update that to a 4. But I feel that that makes people a little less comfortable. So I've switched to this drawing pictures strategy. But there are options for how I want to represent what I've borrowed. Regardless, you should show the borrowing happening because that's a key aspect of the method. Okay. Now let's go to our exercise 7.5, number 1A. We got some space. I think we do. Sure we do. 3201 base 5 minus 2204 base 5. I think I can squeeze it in here. 3, 2, 0, 1, 2, 2, 0, 4. There we go. Okay. Ones column. 1 minus 4. Nope. Not happening. Need to go borrow. There's nothing to borrow. Need to go borrow for that. Okay, there's something. Let's make it blue. So now I move it. I take one of those, so there's one left. Then that one splits into 5. Now, you could use any symbol here. I don't want there to be confusion between a finger and my 1. They're going to look way too similar. So maybe you just want to draw 5 little marks. Just make 5 little marks. It doesn't matter. Right? If I draw a finger now, it looks too similar to my 1. So now I'm going to get confused, and I don't want to confuse myself. So I alter the way I represent things, because this isn't a number representation. I just need to keep track of what I've borrowed. I've borrowed 5 things in this column from the column to the left. How I represent those things, this is just temporary. I just want to show something. Then I need to borrow for the ones column. I'm going to borrow that guy. I always borrow just one. That one comes over and splits into 5 little rocks. Now there's nothing that looks like the rock symbol, so I'm going to be okay. He's gone now. Now I'm in the ones column, and I have 6 things minus 4 is 2. I'm in the next column. I have 4 things minus 0 is 4. Next column, 1 minus 2. Oh no, can't do it. I need to borrow quickly. Let's go with green. That's a dark green. That's nice. Okay. I need to borrow. Let's borrow up there. Again, that is then going to update this 3 to a 2. I always borrow 1. That 1 splits into 5 things. It doesn't actually matter what those things are. I remember their hands, so I want to draw little squares, but it doesn't matter as long as you have 5 markings. That can be distinguished from anything else. So I have in this column 6. 6 take away 2 is 4. 2 take away 2 is nothing. And there we go. So that's equal to 4, 4, 2 base 5. How much is that? I have no idea. I don't even care. It's not the question. The question is to apply the written method for subtraction. Now it looks a little clumsy with all these little markings and symbols and stuff that we're drawing, and it's because we are working in a different number system that's not as familiar, but it emphasizes what I'm borrowing. I'm borrowing that group size always. How I'm representing that is irrelevant. And maybe in the beginning of little Timmy's subtraction learning, it's good to have those borrowing things that they can count off. Whether they use base blocks or whatever, they'll initially see those things that they're borrowing. It'll just be tens instead of fives. So nothing is changing other than the group size being 5 now. I guess we could squeeze in one more. I don't know if we should. We can do a quick one. And then if it's too fast, then you always have the recording, right? But at least we've done more than one in the modern symbols. All right, so I'm lining it up. 3, 1, maybe more space. I hope this isn't a borrowing nightmare. Why do I think it is? 1, 4, 1, 4, because it is. Yeah, that's okay. Now, let's, nah, I should use the color. Color helps. 0 minus 4, can't be done. Let's go borrow. I borrow this guy actually. He comes over, splits into 5 little rocks. Perfect. 5 minus 4 is 1. Write my 5 before I forget. Then I'm in the 5s column, the groups of 5 column. I have nothing. I have nothing there. I should probably write this 0. That's what I have. I need to take away 1, can't be done. Need to borrow. I will borrow this 1, changing that column's value to nothing. Then borrow. I'm just going to make check marks because my fingers look like 1s. I don't want to be confused. Then in that column, I have 5 with the existing 0. So just 5 minus 1 is 4. Next column, 0 minus 4. Nope, can't do it. I need to borrow. I borrow 1, leaving 2 there. How I represent the 5 that it splits into, that's not really important, is it? It's just a helper for me. But in that green rectangle, I only have 5, and I need to take away 4. So I have a word for 5, but I don't have a single symbol for 5. And that's important to realize. And then in the next column, 2 minus 1 is 1. And I'm done. A little quick squeeze one in. But once you get the hang of it, honestly, it's always the same. Whether I'm in Roman, Babylonian, uh, original one-hand system, Devanagari symbols, modern symbols, it's all the same. It's the same method. And it's the method that you'll be teaching one day. You'll just be counting in groups of 10. Nothing changes. But through this process, we're able to really critically look at the method and completely understand every part of it. Well, I hope. Last one, multiplication. All right, so we have exercise 7.6. I'm going to add one at the start. Let's take, let's take a hand. Let's take 2 fingers and maybe 1 rock, and we're going to multiply that by 2. Let's keep it simple. Our method doesn't change. Line things up, multiply by 2. It's going to look a little strange in this one, but that's okay. Method doesn't change, and I'm doing this to emphasize the method, because if I understand the method, I can use any symbols. It doesn't matter. It doesn't matter at all. Understanding beats anything else. 2 times 1, or 2 copies of this, or however you want to say it, is 2. Then I don't have any 0 symbols here, right? I'm going to start in the next finger column. Doesn't actually even matter. 2 copies of these fingers will be 4 fingers. Oh, there's not even any carryover. Next one, next one. Then I'm going to move to the hand. 2 copies of whatever I see in the hand column. It's 2 hands. This one's a little small. Then I add things up. 2 fingers. Whoopsie, only 4. 2 rocks, 4 fingers, 2 hands. Okay, so that one wasn't very interesting. Fair enough, fair enough. Let's see if we can make it bigger. I didn't want the hands and fingers and rocks to get out of hand. Get it? But let's see, maybe something bigger. Let's go Devanagari symbols. It really doesn't matter now, does it? Let's go. Ooh, that's a nice 3. I like that 3. Let's go times. Let's go 4. Why not? Okay, we line it up. Give ourselves some space to work. My 3 was so nice. Now it looks so weird. Struggle to have consistency in these symbols. All right, method doesn't change. 4 times 1, 4. Now I'm going to move on to the next column. So it's all going to be relative to this column. So the ones digit is going to be a 0. So I pad it with a 0, so to speak. Because when I say 4 times 3, it's not really 4 times 3. It's 4 times 3 groups of whatever value place I'm in. And 4 times 3 in our language is 12. But of course, there's no 12 here. We're counting in groups of 5. 12 is 2 groups of 5 and 2 left over. Then I'm moving on to the next column, really whatever place that is in, doesn't even matter because it's all going to be relative. When I say 4 times this place, I really say 4 times this many groups of whatever this place represents. And it's going to start in the corresponding column. So I'm going to pad it with some zeros there. So 4 times 4, I know I have, in my language, I have 16, but I have to do a small conversion. I'm not going to change my language. I'm not going to change my words. That's going to be too much to ask. So I can say 16, but I can't write 16. 16 is going to be, whoops, sorry, that's a terrible 3. Terrible. 3 groups of 5 and 1 left over. Now I'm ready to add. I'm done with that column. Get out of here. 4 for the ones column. 2, oh, that looks like a decimal 2. For the next column. 3 for the next column. 3 for the last column. Method does not change. Does not change. Some people find it easier to work with these symbols because they don't fall into the trap of thinking that it's decimal. I'm not going to look at this and think that I'm working with decimal numbers. It's a visual reminder to count in groups of 5 for me. But some don't like the symbols at all and want to go back to the modern symbols. Then I just have to remember that these are not decimal numbers. So 7.6, the first one is 3041 base 5 times, oh, all right, 2. And again, we're going to keep it simple to just have a single digit number as our second number. There's no need to make that more complicated. There is some questions in the book to get you to think about larger digits, but you don't have to worry about that for the test. So I line it up, 3041. If you said 3041, then slap yourself on the wrist because it is not a thousand number at all. Times 2. 2 times 1, 2. Pretty easy. 2 times 4, well, I'm going to pad it with a 0. 2 times 4 is 8. Yeah, I have a word for that, but there's no symbol, a single symbol for 8. 8 is 1 group of 5 and 3 left over. That was in this column. Now I'm in the next column, pad it with my zeros. 2 times 0, oh, 0. All right, moving on. That was easy. Next column. I'm going to start in that column, so I'm going to pad it with some zeros. 2 times 3 is 6. I have no 6 symbol. 6 is 1 group of 5 and 1 left over. Now I can add 2, 3, 1, 1, 1. That was backwards. So my answer is 11132 base 5. The method doesn't change. That's why we're doing all of this. because arithmetic is what you're going to be spending the largest portion of your teaching time on, I would say, in terms of math. It is such a big thing and a crucial thing. The methods don't change, just the appearance, just the appearance. And if I can flip and flop between different appearances and do them all comfortably, well, then I truly understand the method that's behind it. That is the goal. B. Is B more interesting? I hope so. That's not really more interesting, is it? Maybe I should skip to. I think that's not more interesting either. None of them are interesting. I want to make it as hard as possible. And they all have some small digits in them, making it a little easy. But that's okay. 4, 2, 0, base 5 times 3. 3 times 0, 0. Then I'm going to go to my next column, pad it with a 0 to line everything up. 3 times 2, whoopsie. 3 times 2 is 6. There is no 6 here. 6 is one group of 5 and one left over. Then I'm going to go to my third column, pad it with zeros to help me line things up. Plus, I need to finish the number. I need to pad it with zeros. 3 times 4 again, we've seen this before, is 12. How do I represent 12 in groups of 5? Two groups of 5, 2 left over, and I'm almost done. Add them up, 0, 1, 3, 2. Rarely is there a carryover in the addition. It can happen. We've seen it in Babylonian numbers, but it doesn't happen often. And there we go. I guess we can squeeze in that last one. Why not? And I have space for it too. Wow. Then I guess we should. 1401. I don't think it's very interesting in terms of complexity because of all the ones and zeros. It's going to be pretty small. But nonetheless, it is there. So let us do it. I'm going to multiply by 4, which is the largest single digit I can multiply by, right? So the multiplication and the arithmetic that I do at any single stage is actually quite simple because the numbers are so small. 4 times 1, 4. Then I'm going to go to the next column, pad it with a 0 to line it up. 4 times 0. Oh, wow. Once you get the hang of this, really, I try and not use the word easy, but it should be easy. Then I'm going to the next, going to go to the next column. That is a wobbly 0. I apologize sincerely. I should do a better job. I'm sorry. 4 times 4, 16. How do I represent 16? 16 is a decimal word. It is 3 groups of 5 and 1 left over. Then I'm going to go to my last column, pad it with 0 so everything is lined up. 4 times 1, 4. Yay, I get some more interesting addition. Barely. In the ones column, in the ones column I have a 4. Next column I have a 0. Get all choked up as soon as I'm going to carry over. 1 plus 0 is 1. What is happening to my voice? 3 plus 4 is 7. So that is one group of 5 and 2 left over, and the 1 comes down. That was so beautiful. Finally, it's rare, but a little carryover can happen. And there we go. Base 5 in all its versions. Arithmetic. Any thoughts or questions? So just a reminder that tomorrow is a catch-up session, Q&A session, You bring questions if you have them. Do whatever you want to do with the time, but there's no new lecture until Wednesday. We're taking our time this week. If you have any catch up you need to do, now is the time. Now is the time. But how you use that time is up to you. All right, then we will talk again maybe tomorrow, maybe Wednesday. Until then.